Hello, this is Carl from Cambrian-AI Research. And once again, I have somebody from IBM Research here to talk with you about semiconductors and what IBM Research is doing in the field of semiconductor leadership and how the CHIPS Act may impact both the US economy for an industry for semiconductors and IBM's efforts. Welcome, Mukesh Khare. He's the Vice President of Hybrid Cloud Research.
Thank you. It's great to be with you, Carl, again.
And my pleasure. I enjoy having you. So why don't we just dive right into it? A lot of people always frustrates me. A lot of people are confused about what IBM is doing in the realm of hardware, and specifically in semiconductors. So can you tell us a little bit about what IBM's leadership in semiconductors and what the role of the Albany Center is in guiding those efforts?
Yeah, that's great. Thank you for the question. Well, IBM, as you know, continues to and has been investing and leading in semiconductor research and development for many decades. In fact, some of the very early work in the space of semiconductors, like the scaling principles on how do you make transistors smaller at the physical level, at the electrical level, that came out of IBM research, or invention of a DRAM capacitor came out of IBM. So we've been in the field of semiconductor research and pushing the boundaries for a long time, for several decades. And we have continued to maintain that till today. And just to give you a few examples, in 2015, we were very proud to announce world's first 7 nanometer chip technology at Albany Nanotech using EUV lithography. So that was a very recent but very important announcement. And the reason that connects, because now we are able to ship our product using 7 nanometer chip technology that we had actually announced several years back. And then we worked with Samsung as our foundry partner. They supplied our product chips, and now they're part of our both IBM Z system as well as IBM Power system that we have announced in the last 2 years. Now, IBM systems business continues to have very aggressive performance and reliability, as well as differentiating features requirement that are critical for the mission critical workload that they are driving for the entire industry. In fact, IBM system continues to have a very significant presence in financial services and other regulated industry. And the job for IBM semiconductor research and development team is to continue to develop leadership technology so that we can get those chips built and to create differentiated offering in our product and services. To continue the journey of some of the exciting innovation coming out of IBM research in semiconductor, in 2017, we announced the next device structure beyond FinFET. And that was a major breakthrough. There was a lot of work done in the past. IBM itself had worked for more than 10 years before that to perfect that structure. We called it nanosheet device structure. And we are very proud that the nanosheet device structure has now become standard for all of the leading edge foundries beyond FinFET. And that's a power of both pushing the limits, understanding the product need, as well as having a broad ecosystem of partners who can then create a much broader adoption of these type of technologies. And in fact, last year in 2021, we announced world's first 2 nanometer chip technology using that nanosheet device structure, but also perfecting it in terms of lithography, newer spacer technology, newer isolation technology, putting in the right ground rule. So we continue to, at IBM Research, continue to drive technology innovation in semiconductor field with our partners, which helps IBM's products as well as products of our partners. Now, the second part that you asked about was the Albany Nanotech Center. We are very proud to be part of Albany Nanotech Center. In fact, this center started almost 20 years ago in partnership with New York State, IBM, as well as Tokyo Electron, who are original partners. And ever since, many companies have joined this broad ecosystem. I will say, this is one of the very few such ecosystem that exist where public, private, and academic, all three come together to create most advanced technologies, and which has both impact to our business as well as academic to create the next generation of workforce that is needed for semiconductor. So we IBM is present here, and this is our facility for driving leadership semiconductor technology.
Interesting. So obviously chips are in the news a lot this year between the falling prices of many chip company stocks, the global tension that is swirling around the ability to buy, sell, and manufacture, design chips. The entire life cycle is now all very political and very important to economies around the world. So why are semiconductors so important? You're spending a lot of money. You've got some of the best PhDs in materials sciences and computer science and electrical engineering working for you. Why does IBM continue to drive these investments?
Well, semiconductor are I'll say one of the foundational technology which drives a lot of other technological products and services. Software doesn't run on in air. It needs semiconductor to run those software. IBM cares about it because we build mission critical systems. We need for those systems and our cloud business. We need very high performing, very reliable semiconductor technology, and that's how we differentiate the needs of our client. IBM is a full stack company, as we have talked about last time, right? So once we understand the need of our client, we can then convert that into the right application, software, and then hardware. So IBM continues to have both hardware as well as software business, and semiconductor is at the heart of it. So it's very critical for IBM's business, and that's why we continue to invest in that technology. Semiconductor is also very critical for the infrastructure for the world. We all saw during pandemic, we all started working from home. It's the semiconductor technology that enabled us to be able to work from home, to be able to get on the Zoom call like this, to be able to communicate all over the world and still continue to do our job and continue to have an impact to society. So semiconductor is very critical. I think pandemic underscores that, and the stress in the semiconductor supply chain made semiconductor a dinner table conversation. When you can't buy a car, or you cannot get your refrigerator fixed because some semiconductor is missing, everyone understood how critical this technology is. And we are very fortunate that US and the world is really paying attention to such a foundational technology.
Yeah, absolutely. It is at the foundation of so many things these days, and is obviously important enough that the United States government has decided to pass legislation. And I know President Biden was visiting IBM just recently and talking about that legislation. But can you share with us a little bit about what are the main provisions of the CHIPS Act? And then we can talk a little bit about how that impacts IBM.
Yeah, US CHIPS Act was one of the first act in the world which started, national level focus and investment to reinvigorate, semiconductor industry and develop a much balanced supply chain. Because especially during pandemic, we realized that how fragile semiconductor supply chain is or can get, and how big its impact could be for every part of our business, as well as national security. And the CHIPS Act, the CHIPS Act is I'll say it's a once in a generation opportunity. It's a very comprehensive act. It looks at the full supply chain, if I look at it for semiconductor, it's not just focusing on manufacturing. Manufacturing is very important, no doubt about it. However, in semiconductor world, manufacturing without focus on research and development and without focus on workforce development is just not practical. Just not practical. You need significant focus and investment in R&D, which can then feed into the manufacturing. You need focus on workforce development so that we have workforce for future that can get jobs in those manufacturing facilities, in those R&D facilities. So this CHIPS Act actually covers all three aspects. It covers incentives towards the manufacturing aspect. It covers, it incentivizes creation of a national R&D initiative called National Semiconductor Research and Development Center, NSTC, creation of such center that can bring more companies to participate in the semiconductor journey. One of the challenge with semiconductor industry is the barrier to entry is very high. And creation of R&D agenda and creation of NSTC is to enable to reduce the barrier of entry. So more companies, more startups, more universities can participate in the semiconductor journey. And then there is a focus on workforce development. How can we get more students educated and trained in the art of semiconductor, not at the PhD level only, but also at undergrad level, community college level, even get excitement in this high school level so that we have the next generation of engineers and workforce that can participate in this field. So CHIPS Act is a very comprehensive act, and we are very proud that the US took the lead and got the act passed, and now we are all participating in to help shape implementation.
Mm-hmm. So how do you envision this foundation that the CHIPS Act is reinforcing? How do you envision that will impact American competitiveness on the global marketplace, both in terms of manufacturing, but also in terms of, we have the lead today in advanced semiconductors, right? Whether CPUs or GPUs or networking chips. How do you envision the CHIPS Act will further that leadership or maintain that leadership in the face of increasing global competition?
Well, I wanted to first clarify that as of today, the most advanced semiconductor technology is not manufactured in the US.
No,
right? So the US only manufactures maybe 12% of the semiconductors now. And the most advanced manufacturing of logic technology is in Asia. So clearly there is a imbalance in the supply chain for leadership semiconductor technology, right? US CHIPS Act does help to address this, help to find a more balanced approach for the supply chain. It's incentivizing both advanced manufacturing in the US as well as advanced R&D in the US. So clearly this will help US semiconductor industry, as well as it has provisions to partner with like-minded countries, because we have to accept that semiconductor industry is a global industry. So which countries and which regions we should partner, and that's part of CHIPS Act. It does allow us to partner so that the supply chain for semiconductor in the like-minded countries becomes more robust and stronger, and we can help each other, in the growth of semiconductor leadership or semiconductor industry. So it's a positive, it's a step in the positive direction. It will make semiconductor industry more competitive in the US. It will improve R&D ecosystem in the US, as well as it will help create a stronger workforce that can serve both the manufacturing as well as R&D needs of semiconductors.
Interesting. So very worthwhile goals. What role do you see Albany having in going forward with the impact of the CHIPS Act?
Yeah, so today I'm talking with you from Albany Nanotech Complex. As I had mentioned earlier on, Albany Nanotech is very unique and the only such capability in the United States, which is a public, private, and academic partnership. There is significant investment that's already made on this site. More than $15 billion have been invested here to create this huge ecosystem of various entities, as I just talked about. Many leading edge companies are here already. As equipment companies, material companies, chip companies, design companies, we are all partnering on this site in New York. So this center can act as one of the hubs of this National Semiconductor Technology Center and jumpstart the national initiative. We don't have time to waste. We cannot go in a greenfield and try to recreate Albany, which took us 20 years to create. And the Albany Nanotech Center can get the national R&D initiative started within 6 months of when we are told to go. So we have the fabs ready. We have the partnership ecosystem, and we just have to make sure that we align our agenda to a national level and allow for more partners and to participate and provide the right prototyping capability that the National R&D Center desires. So we are very proud that we are part of Albany Nanotech Complex, and Albany Nanotech is very well positioned to help jumpstart the National Semiconductor Technology Center initiative going forward.
Excellent, excellent. I think we're very fortunate to have IBM research leadership in semiconductors to help lead and guide this effort at the national and international scale. So thank you for your time today. It's been very enlightening for me, and I look forward to talking with you again soon.
Thank you. Great talking with you, Carl.
Take care now. Bye-bye.
Bye.